Another thing I'd like to take a few moments to discuss is a technology or technique called SQL injection. And SQL injection is basically a technique that allows attackers to steal valuable database information, usually involving things like user account information, personal data, financial data, for example. And it actually relies on poor data validation and poor statement checking. And I want to kind of clarify that for a minute. When you build an application, you have to choose what type of field is going to exist, for example, in that application. So one field might be username and one field might be password. And those fields have data types. Username is probably text, and password is probably going to be a password data type because it will put asterisks up instead of the actual letters. So if you don't restrict the data types and restrict the number of characters and the type of characters you can put into that individual form, then that means I can type anything that I want. And if that data is being interpreted somewhere, then I can actually reinterpret it or change how it will be interpreted. So we're going to rely on that bad or poor data validation so that when the application goes to talk to the database, usually a Microsoft SQL database, then we will successfully retrieve information we shouldn't have been able to access. And what this ends up being for us is modifying the SQL statement itself. A lot of applications use SQL authentication. And really what SQL authentication boils down to is a select statement where username is equal to and what you've typed in, and password is equal to and then the resulting hash of that password. Well, all we have to do is modify or append values to that SQL statement so that it retrieves data instead of checks against a validation or whatever the case may be. Remember, SQL isn't always intelligent enough, if it's not configured that way, to determine the difference between an authentication query and a data request query. So if we trick it into thinking that a request is the same as an authentication or a submit is the same as a request, SQL is just going to process the information that's given to it. We can usually use SQL injection to circumvent authentication altogether or actually remove restrictions that are placed on standard application functions. For example, application A might have a restriction that you can only return one database record at a time. Well, by providing the SQL statement with a little bit of modification and sending it to the database, then we might be able to retrieve the first 10 records or the first 5,000 records, ultimately circumventing the application intent. Usually, SQL injection is restricted to web servers or web applications with SQL ANSI 92 enabled databases like MS SQL, Oracle, MySQL, and various databases that might be popular at any given time. So it's not just going to affect these web applications, but that's usually the easiest for an attacker to get to and therefore is utilized as an attack vector. But if you can get access to other database applications, such as end-user database applications, you can most likely perform the same level of SQL injection that you could with a web server. The only real protection against SQL injection is to use proper data validation techniques and restrict the type and number of queries that can be sent to the SQL server. So that way you're not relying on the SQL server to correctly interpret the intent of the application query. There are some levels of database configuration that can be useful, but for the most part, we want to protect ourselves at the application layer. Although we can usually change some permissions around or set up some restrictions on the type of queries that we're sending, we want to rely more on that front end or that second tier of the application structure.